Welcome to Solving Multi-Step Equations Day 2. Today we're going to take a look at solving consecutive integer problems. So as we look at solving consecutive integer problems, we need to understand what in the world a consecutive integer is. They're counting numbers, okay, things that would be on our number line, and if we're given the term consecutive integer, it's things that are one away from each other. So 7, 8, 9. If I said n equals the first integer, okay, to get the second integer, if they're consecutive, we could go n plus 1. And then to get this next one in the sequence, we would have n plus 2. Okay? And that would be if they are consecutive integers and they're one away from each other. The other term that we're going to run across is going to either be consecutive even integers or consecutive odd integers. And as you look at those, how far away is each number from the previous one? So if I take the first list, -4, -2, 0, how far away are those from each other? If we said n is the first integer, to get to the next integer we would need to go n plus 2, and the third one would be n plus 4, and the pattern would continue. This is true even if they are odd integers, like -3, -1, 1, 3. If I call -3 my first integer, that could be n. N plus 2 would get me to -1. N plus 4 would get me to the next one. So even though they're consecutive even or consecutive odd integers, we can add 2, add 4. If I wanted to continue the pattern, I could go n plus 6 to get to the next term. So we'll use that set of information as we work through the next couple problems. Again, as you watch the video, if there's questions, if there's things you're not clear on, please jot down notes and bring those to class with you. So here we're trying to write an equation as well as solve the problem. So the sum of 3 consecutive even integers is -42. In this case, the integers, because they're even, my first integer is n. And every other integer I'm going to name in relation to that. If I go n plus 2, I'll get my second integer. And n plus 4 will get me to my third integer. So knowing that information, kind of defined my variables, I know that n plus, so this is my first integer, here's my next integer, n plus 2 plus n plus 4 ends up equaling -42. Now it's just combining like terms and simplifying the equation. N plus n plus n is 3n, and then 2 plus 4 is 6. So we have 3n plus 6 equals -42. At this point I can subtract 6 from both sides, and I have 3n. I need to keep in mind here I have a negative minus a negative, so it's adding, and I get to -48. Okay, at this point I can divide by 3, and the first integer, n, equals -48 divided by 3, or -16. So over here, I know that n is -16. To get my second integer, I can go -16 plus 2. So this is -16. -16 plus 2 would be -14. -16 plus 4 ends up being -12. And I can check to see if this works. And I'm going to switch to a third color here, black. And I can just simply go negative 16, negative 14, negative 12. If I add those, I should get to what I was trying to, negative 42. 6 plus 4 is 10, 10 plus 2 is 12. And so I have 42. I need to keep in mind these are all negative, so it does work. Okay. Here, this one's a little bit similar, except I have just consecutive integers. In this case, I have n being my first integer. The next one, because they're consecutive, it could be 3, 4, 5. Those aren't my answers. But if in that situation, I'm only adding 1 to get to my second integer, to my third integer, I'm adding 2. Okay, so this is going to be my first integer, my second, and my third integer. I'm going to take that information to write my equation, n plus my second integer, which happens to be n plus 1, plus my next integer, n plus 2. So here I can go ahead and that's going to equal 21. Here I can go ahead and add like terms. N plus n is 3n. 1 plus 2 is 3, so I have 3n plus 3 equals 21. Now at this point it's just solving a multi-step equation. Minus 3 minus 3, we get 3n equals 18. Divide by 3, divide by 3, and we end up with n equals 6. So my first integer or n is 6. If I add 1 to 6, I get 7. If I add 2 to 6, I get 8. Okay, so go ahead, hit pause, try these, and see how it goes for you. Okay, in this case it's consecutive, so that's going to be one right after another, not a space in between. So it's 3, so I have n plus 1 plus n plus 2. A lot of times I like to put parentheses around the different integers, and that's going to get us to 96. That ends up being 3n plus 3 equals 96. Subtract 3, subtract 3. That leaves us with 3n equals 93. If we divide that by 3, divide that by 3, we get the statement that n equals 31. So n equals 31, n plus 1 will be 32, and n plus 2 equals 33. If I add those up, if I want to check my work, 1 plus 2 is 3, plus 3, that is going to be 6. And then add the next column, I get 96 as my answer. And they do check out with each other. Here I only have 2 consecutive integers. I'll go ahead and try a different color. And they're odd. Okay, again, even though they're odd, my first integer is n. My next integer is going to be 2 away, so it's n plus 2. And that's going to equal 176. So in this case, I have 2n plus 2 equals 176. Subtract 2, subtract 2. We end up with 2n equals 174. At this point, if I divide by 2, I get the statement that n equals 2 into 174. It's going to be 8, 16. So n is 87. So my first integer is 87. My next integer is n plus 2. So I add 2 to 87 and I get to 89. Again, if I want to add those, I can and check my work. 7 plus 9 is 16. Carry the 1. 16 and 1 is 17. So it does check out. So, hopefully this makes sense. Again, please bring any questions you might have to class tomorrow.